Good evening, everyone. Good evening, friends. Welcome back to our sessions on Python for AI. So we have completed 21 days successfully, and today is our 22nd day of this particular program where we are going to start a new topic, right? So it's a new topic that is functions. We are going to understand functions in Python. Okay, so from scratch, okay, we are going to understand each and every topic as part of functions. The purpose of using a function, then followed by the definition of a function. What exactly is a function? We'll understand, followed by the parts. What are the parts that we have in a function? In Python function, we'll have some parts. Okay, so the parts of function will be understood. Then we'll also understand the phases of function and the syntax for defining functions in Python. How we have to define a function in Python? The syntax. We'll understand the syntax. Then, in order to define these functions, there are some approaches. We have 4 approaches, and we will be understanding all the 4 approaches, followed by the examples, the use cases for each and every approach. Right? Post understanding the topics related to functions, we have arguments and parameters coming into the picture. Okay, so what is an argument? What is a parameter? And what are the types of arguments that we have? Will be explained. Then we also have global and local parameters. Okay, so there are global and local parameters, right? Then we also have global keyword, where we are supposed to use this global keyword and the global function. We will be understanding it, followed by the lambda functions, also called as anonymous functions. Okay, so what is the meaning for lambda function? How we have to define a lambda function? The syntax, each and every topic will be explained here. And finally, the special functions in Python, where we have map, reduce, and filter. Right? So all these topics we are going to cover as part of functions. Very, very, very important topic. If you are going to keep Python as one of your skill in your resume, for sure you can expect a question from functions. So the importance is very high for this particular topic. So friends, pay attention. In the same way, if you're joining for the first time, consider subscribing our channel, because we are going to come up with amazing content in future, right? So in order to get all the notifications, just subscribe to our channel, Nextera Unitech. Right. So without no further delay, let's get started. Let us understand the purpose of functions. I'll go back. Probably, I have to talk about the types of programming languages. You take any programming language, okay? So in the context of functional approach, programming languages are broadly classified into 2 types. Are you guys aware of it? Probably many of us are not aware of this particular thing, right? Yes. Let us understand what are the 2 types of programming languages we have when we are speaking with respect to the context of functional approach. The first one is called unstructured programming language, and the second type is called structured programming language. Unstructured and structured programming languages. Right? Yes. So what is unstructured programming language and what is structured programming language? Let us understand, guys. Okay. Yes. Initially, let us understand what exactly is unstructured programming language. A language which does not contain the concept of functions. In a programming language, there is no concept of functions. So such kind of programming languages are called unstructured programming languages. And because of there is no concept of functions, we are unable to use the code. The code that we have written cannot be used for multiple times. And because of this, unstructured programming languages have some limitations. There are some limitations for unstructured programming language just because of not having functions as the concept. What are they? Whenever to build an application, to develop an application, the time will become more. Yes. Why? There is no concept of functions. If there is no function, if I'm unable to define a function within the programming language, obviously I have to keep on developing the program. Yes. So the application development time will be more, followed by it takes more memory space. As you are repeating the same code time again, the memory space will be occupied. The application, whatever you are trying to build, takes more memory space. Then execution time, again, it will be more. More number of lines? Yes. So obviously the time gets, more. The execution time gets more. When the execution time is more, the performance will be degraded. If when you take the performance, it gets degraded for that particular application, which you are trying to build using unstructured programming language. And this is the common point. You'll have the duplication, the repetition of the code. You're keeping on repeating, right? So you'll have redundancy within your Python program. Within the program, for the application, you'll find the redundancy. And one of such kind of unstructured programming language is GW Basic. There is a programming language called GW Basic. This is very old programming language. Okay. So very easy and simplest programming language, but it is an unstructured programming language which does not have the concept of functions. Just not having the concept of functions, there are n number of limitations, challenges. Okay. So just because of this, then structured programming languages came into the picture. Then structured programming languages came into the picture. So what is the meaning of structured programming language? A structured programming language is a programming language which contains the concept of functions. Unstructured, which does not contain the concept of functions. And structured, yes, it contains the concept of functions. That means we can create functions. We can use functions in a structured programming language. When you have function, yes, code reusability is present. Just we have functions in structured programming languages, we have multiple advantages. There are multiple advantages. Whatever the limitations that unstructured programming language has, all of them, were being addressed by structured programming language. The development time gets reduced. Why? You are defining a function, and wherever you want to use it, yes, it allows us to use the code reusability. Then the time, apart from time, we also have the memory. Okay, since we are not repeating the lines, we are using the same function time again, the application takes less memory. Okay, the space in the memory, yes. Then we also have an additional advantage that the execution time gets less. Very quickly, we are able to execute the application, the code, and finally the performance gets enhanced. It improves. And when it comes to the duplication and the repetition, obviously it gets minimized. Why? We are able to use a function, and this function helps us to address the issue of redundancy, the duplication. The best examples are, you take any programming languages, the modern programming languages, C, COBOL, C++, Python, Java, .NET. All of these are structured programming languages, which means all these programming languages contains the concept of functions. We can create functions, right? Yes. So this is the history that we have with respect to functions. So based on functions, programming languages are broadly classified into two types: unstructured and structured. If we are using any unstructured programming language, we cannot create a function using an unstructured programming language, where we have multiple limitations, and all of these limitations were being addressed by structured programming language. And whatever the programming languages that we are using, that we are learning as part of these sessions, Python is an example of structured programming language, right? So now let us understand what exactly is a function. What is a function? What is the purpose of using a function in the program? Is, when it comes to function, the purpose of using the concept of functions is they help us to perform certain operations. So fixed operations can be performed, where it provides code reusability. We can time again reuse the code. So this is one of the important aspect coming to the topic of functions. Okay, so when it comes to the functions, a function helps us to reuse the code. Whatever the code that we keep for a function, that can be reused. Right? Yes. Now, let me define a function. A function is nothing but subprogram of a main program. Within the main program, you take any subprogram. So this is a function, or a part of main program is called a function. Is called a function. Right? Then coming to the parts of function, within a function, you'll generally find two parts. Okay, so what are these two parts? Let us understand, friends. They are function definition and function call. function definition and other one is function call. So when it comes to function definition will exist only once. Okay, so we have to define the function, right? And this can be existed only for once. And we can have multiple function calls. Function calls refers to calling the function. Once after defining the function, we are supposed to, whenever we want to reuse it, we'll call the function. So across the program, we can have multiple function calls, but function definition will just exist only for once. Once if you define, yes, you can reuse it. Across the program, you can reuse it. Right? Then coming to the parts, we have two parts in a function. One is function definition and function calls. A function definition will exist only for once, but we can have multiple function calls. Then for each function call, for every function call, there must exist a function definition. So this means without defining a function, we cannot call it. So before you call it, we have to define it. There must exist a function definition. If you don't define the function, then if you try to call it, you'll get a name error. You'll get an error called name error. Right? So these are the parts of function. Within a function, we'll have two parts. Function definition, where we define our function. Function call is where we call the function. Whatever the function that got defined will be called. So within a program, you'll have function definition existing for only once, but function calls you'll have for multiple. You can have multiple function calls. Before you call a function, ensure that the function has been defined. If not, you'll get an error. What error? It will be a name error. It will be a name error. Right? Yes. Now, let us also understand the syntax for defining a function in Python. Within a Python, for whatever things we do, okay, it might be conditional statements, even for data types, we have understood syntaxes. How we are supposed to define a object. Right? In the same way, there is a syntax for defining a function in Python. Okay, so what is this syntax? What is the syntax that has to be followed for defining a function? Is every time, whenever you are defining a function, ensure that the function starts with the keyword def. It starts with the keyword def. Then followed by the function name. Whatever you want to keep, I mean the name that you would like to keep for the function, that comes into the picture. Next, def keyword followed by function name, then parenthesis. Within the parenthesis, we have to pass a list of formal arguments, formal parameters. Okay, so any parameters, arguments, then followed by indentation symbol. Followed by indentation symbol. Now we'll have our block of statements down to it. So these are our lines of code. Block of statements. But before block of statements, ensure you keep a doc string. So what is this doc string? This doc string helps us to explain the functionality of a function. Okay, so whenever you are defining your function, okay, ensure that you keep a doc string, which whenever a new person, a third person enters into the picture, okay, for better understanding, if he or she goes through this particular string, doc string, also called as documentation string, this particular doc string helps them to quickly understand the functionality of the function. Okay, so the best practice, whenever you are defining your function, if you are able to use this doc string, well appreciated, because not every time you will be working on the same task in real time, right? Your work will be shared across your team. So whenever your team goes through your work, for easy understanding, you know, especially a function, we have docstring, right? So this is the syntax for defining a function. I repeat, def keyword followed by function name. Then next to the function name, we'll have parenthesis. In the parenthesis, we pass parameters. Then next to it, we'll have indentation symbol. Then our blocks of statements. Then we'll have block of statements, our logic. Whatever the operations that we would like to perform, all the operations, we can list it here. Okay, but ensure that dot string is present as part of these block of statements. Okay, so that is actually the good practice, right? Yes. So probably now we got a good understanding with respect to functions. What exactly is a function? A function is a subprogram in a main program. A part of main program is a function. What is the purpose of using function? Function helps us to perform some operations where it provides code reusability across the program. Then, how many parts we have in function? We have two parts. What are they? First one is function definition, and the second one is function call. Function call, right? And we also have understood the syntax for defining a function. I hope it is very clear because very small topic. Okay, it's a very big topic and we just understood only a few topics, subtopics, right? So before we go and understand the next topic, we'll quickly go through some examples and let us understand more about functions. Let us go and do some hands-on. Right. It's function call. Okay. Anyways, let's get started. So I'm coming with the Python program. Okay. So where we are going to calculate all the arithmetic operations by using functions. Okay. So we are using functions and we are going to perform all the arithmetic operations. For each and every arithmetic operation, I am coming up with a function. Just have a look. 1, 2, 3, 4, 5, and 6. Okay, so let me start with the first one. What is the syntax for defining a function? Def keyword followed by the function name. Def keyword followed by the function name. What is our function name? ADDOP, which means add operation. Which means add operation. Then next to it, we have parenthesis. We have parenthesis. Then followed by indentation symbol. Once after keeping indentation symbol, we can have our block of statements. The operations that has to be executed, we can have down to it. Clear? Simple. def keyword followed by function name. Then next to it we have parenthesis and indentation symbol. Okay. Down to it we have our block of statements one by one. How many statements we have? 3. Why? You see the spaces in front of these 3 lines? Yes. So only these 3 lines are part of our function, add operation. So here we are defining our function, function definition, and in line number 3760, we are calling it 2 parts. For a function, we have 2 parts. One is defining function definition and the other one is function call. Right? Yes. Now let us understand. So friends, it's your turn because we have understood the function syntax. Yes. Now just map with the syntax and try to understand the block of statements. What are we doing in this function? What are we doing? So in the function, we are using input and float functions to read the data. Input function, which helps us to read the data from the keyboard. Okay. And by default, the value gets stored in using str type. And this str type data gets converted to float type. Right. So obviously, we cannot perform addition operation on str type values, str type data. So what we are doing? We are performing type conversion. And that value gets stored in A. In the same way, we are coming up with one more similar line. Okay. And the second value gets stored in B. In the third line of the function, we are using print function to print a message in which formatting gets done, string formatting gets done, where the values of A and B as well as A plus B gets formatted at respective positions. So the output will be sum of A comma B is equals to A plus B. Clear? So let me execute, guys. First of all, let me define the function. So in the same way, you have to execute all the lines, not just one line. If you have 10 lines, ensure that all the 10 lines are selected and execute. So I'm executing. Done. Done. So that means we have defined the function. The function got defined. So once after defining the function, we can call the function for multiple times within the same program. So within this script, I can call addop function for multiple times. So that is nothing but code reusability only. Right? So what we are doing in the next line, 3760, we are calling the function add operation. I'll just execute this. Have a look. You see in the console. So that means the function was called in which these lines get executed in the backend. Okay, in the backend, it is executing all the lines one by one. So what is the first line it has executed? You see, it is asking us to enter the first value for addition. So let me keep it as 5. Then I'll click on enter. In the same way, immediately it is asking us to enter second value for addition. Okay, let me also, give a value, probably 3 for the second value. So tell me the values of A, B and A plus B, because that is what gets printed. Sum of A comma B is equals to A plus B will be our output. So what will be the value that will be stored in A, then in B and the sum? I want everyone to respond. Okay, okay. Will it be 5 comma 3 or 5.0 comma 3.0? What do you say, my friend? Hmm? Hmm? The output will be 5.3 comma 5.0 comma 3.0 is equal to 8.0. Good, good. Let me click on enter. You see? You see here? Why? Because the value that we are passing is getting converted to float. Is getting converted to float. So that means we'll have the value in floating values, decimal values. 5 gets converted to 5.0, 3 gets converted to 3.0, and obviously the sum of two float values, float type value is again a float value only. Clear? Good. Right. So the first function we have understood. Now let me go to the next function. Probably I'll not talk much. Okay, you guys have to respond for the second function. What are we doing? We are defining a function again? Yes. What is the name of our function? Sub OP. Subtraction operation. Okay, so I'm just using the same code as it is, but just changing the operation. Instead of addition, I'm changing the operation to subtraction. Okay, so even I'm changing the variables as well. Anyways, let me define the function. So executing all the lines of code together and it got executed. Once after defining the function, I'm going to call the function. I'm calling the function. Right? So let me call it. The moment you call the function, it starts executing the function that was defined. So it is asking us to enter the first value for subtraction. I'll keep it as 5, the first value, and the second value I'll keep it as 3. So what will be the output for this function call? Good. Sub of 5.0 comma 3.0 is equals to 2.0 will be our output. Clear? Then, in the same way, we have one more function defining for multiplication. The same code, friends. I'm just changing the operation, nothing else. Changing the function name, then we are also changing the operation. The operator is being changed. Here we are going to define a function which helps us to perform multiplication. Done. We are done. Then we are calling the function that got defined. We are calling the function which got defined. In the same way, it is asking us to enter the values. So I'll pass 5 and the same. The next value is 3. Good. Mul of 5.0 comma 3.0 is equals to 15.0 will be our output. Clear? Right. In the same way, let me also create a function for performing division as well as floor division. Okay. And I'm naming the function as divop, divop, division operation. And what are the operations that we are performing? Division, floor division. So let me define our function. I'm defining the function initially, then calling the function that got defined. Calling the function divop. Okay, now I am passing the values 5 and 3. So what will be the output, friends? What will be the output? We are performing division as well as floor division. What will be the output? No, for division it will return. What happened? For division it will return the coefficient 1.666 so on. 5 divided by 3. So 1.66 something you'll get, right? So on. But floor division will return as only the base. The floor value. Where the output will be 1. Let me click on execute. It is 1.666 so on 7. Right? Yes. Now, let me go to the next function. Where we are defining a function for modular operation. Modular operation. Okay. So using the same code, just changing the operator, percentage, modular operator. I'm defining it. What does the modular operator return? It returns the remainder. So I'm calling the function mod op and I'm passing the values. The first value as 5 and the second value as 3. What will be the output? A modular operator returns reminder 5, modular operator 3. What will be our output? It will be 2.0. Good. 2.0 will be our output, guys. Then the last function, it is exponential operator. Okay. Expo OP is the function name which helps us to, calculate the power. So let me define the function. Done? Yes. Then I'm also calling the function that got defined and I'll pass the values. So it is asking us to enter the value for base. Probably let me take a small number 2, which gets converted to float value 2.0. And let me also pass a value for power. I'll keep it as 3. So 2 power 3, it is 8. But as the values are getting converted to float, the output will be 8.0. Anyways, if you are trying with 5 and 3, that is also accepted. Right. So how many functions did we create? 6 functions. Whatever might be the number, we can pass. By just calling the function, we can get the, operation done. Whatever it might be, the numbers, okay, we have defined the functions for all the arithmetic operations. Right, clear? A very sample and simple examples for functions. Now, coming to the next program, we are also, defining functions for all the arithmetic operations in the same way, but there is a slight difference between this program and the previous one. What makes the difference is we'll understand. Okay, so earlier what happened? If you see, under each and every function, when we are defining the function, we are, using float and the input function. Okay, so when you call the function, it is accepting. It is accepting the values, converting to float, type conversion is being done, and then the operation is being performed. But here, we just made a small change. It is, we are creating a function, we are defining a function to accept the values alone. To accept the values alone, we are creating a function. We are defining a function. Okay, and the function name that I'm going to give is read values. Read values. And do we have any parameter? Yes, there is a parameter called OP. Now, let us map with the syntax of function. What is the syntax of function? def keyword followed by function name. It is read values, and next to function name you will have parenthesis. In parenthesis we can have parameters. We'll have parameters. What is this parameter? What are the arguments? Everything we'll understand, friends. Okay. For time being, assume parameters are the values that you pass inside parenthesis, the regular braces. Then indentation symbol, your block of statements, the operations that has to be executed, in which We are defining a function just to read the values, the two values that we are passing. So in order to read them, we are defining a function. Simple? Yes. So let me define it first of all. And we have a written keyword. And the last line under this function, there is a keyword used. It is return. A return keyword helps us to return the values, either a single value or multiple values in a function. In a function, you generally use a keyword named as return, which returns the values. It might be a single value or multiple values. So let me execute. Yes. So that means we have defined the function read values. Done. Now I'm defining the function for addition operation. Is it the same? Yes. But there is a small difference. Earlier, we have defined the same function addop, add operation, okay, in which we have a and b, the variables a and b, where the values are getting a same. But here, from where the values are getting read? From the previous function. So I'm using read values function inside this add operation function. Okay, and what is the operation that I'm using, friends? Addition. I'm just passing a, sequence of characters. So it has to take a parameter. A value has to be passed into the function. So I'm passing it. So initially, this function that executes and it accepts the values of a and b, where the values of a and b will be assigned to x and y. How? Because of return keyword, which returns a comma b, and these values of a comma b will be assigned to x, y. What is this? Multi-line assignment is being done. Then, as usual, it prints the output. It performs formatting. It prints x, y, and the sum. So this line did not change. Line number 3802 did not change. But here we have the difference. We are using a function inside a function. Yes, we are calling it. Strictly speaking, we are calling read values function inside add operation function. So let me execute, friends. I'm executing. Done. Now the function got defined. Let me call the function. Calling it. As usual, it is asking us to enter two values. So the first value I'll keep it as 5 and the second value as 3. Did we get the same output? Yes. We'll get the same output, but there is a difference between this program and the previous program. Right? So in this way, I'll execute all the functions, friends. Okay. So I'll define a function for subtraction operation, done, which reads the values from read values function. It reads the values from read values function. Then calling the function sub op, where it asks us to enter the first value. So keeping it as 5 and the second value as 3. So the output will be 2.0. 2.0. Simple, right? Then in the same way, let us also define a function for multiplication. Done. Now I'll go and call the function. Once after defining it, we can call the function for multiple times. Okay. So I'm just passing the same values 5 and 3 for x and y. So the output will be 15.0. Then the division operation, the function has division operation where it performs division as well as floor division. So I'm defining it and calling it. So passing the same values 5 and 3, the output will be same. There is no change in the output, but what we are trying to understand is the change between the programs that we are understanding. Program 1 and the program 2, there is a difference. The read values function. So this was implemented in this program 2. But earlier, no. Under each and every function, it is accepting the values using input function. Right? Yes. Then creating or defining one more function. Defining one more function, mod OP, modular operator, which returns reminder. Then calling it. And let us pass the values for the modular division. 5 and 3. Obviously, the output will be 1.0. Sorry, 2.0. Modular, right? Reminder. My bad. And finally, we have the exponential operation. Okay. And we are executing it as is. Calling it. Where we'll pass a value for base and power. The output will be 125.0. Simple, guys. So the only difference that you have observed is we have created a function just to read the values, the two values from the keyboard. Okay, for that specific task, we created a function alone, and that function was being called in all these functions. In all these operation functions, we are calling the same function again. Simple. Now, from here onwards, we are going to understand functions, how multiple functions are being created, are being defined. And here we have a program for accepting list of names. We are defining a function for accepting a list of names, a list. So initially a function is being defined to read the names. Then the second function is to display the names. The third function is to sort the names in both ascending and descending order. So in total, we have three functions getting defined as part of this program, where we are going to work on list object. Ready? Yes. Let's get started. Right. So I'm creating a function, I'm defining a function where this function, I'm giving a name for the function as read names. What is the name of the function? Read names. Okay. Are we passing any arguments, parameters? No. No parameters. Then indentation symbol, and down to it we'll have our block of statements. So what is the first line inside the function? So it is asking us, enter how many number of names would you like to have? Okay. So here we'll pass a number and that gets converted to int type value. Then we have a if else statement. If else conditional statement is what we are using. First, suppose, from the keyboard, if a negative integer was being written, it was accepted, the condition will hold true. Yes. If n value, if it is a negative integer, obviously it will be less than 0. Even what if a 0 was being entered? Okay, it accepts initially, but it checks for the condition. As this condition holds true, it returns none. Nothing will be returned. But what if the condition is false? If I enter a value for n as a positive number, positive integer, this condition will become false. It enters else block by skipping if block. In else block, it starts executing line by line, where it initially creates an empty list object and that gets stored in LST. Okay, so even in the last class, we have discussed different approaches to create an empty list object. One is list function, the other one is using square braces. We can use square braces or list function. List function can be used to create an empty list object. So initially creating an empty list object and storing it in a variable LST. Then what do we have? We have a for loop. Syntax for loop. For keyword, variable name in an iterable object. What is the iterable object that we are coming up with, friends? We are using a range function in order to use it as an iterable object. So range of n plus 1, it will be our iterable object. Whatever the value that we pass for n, assume if we are passing for n as 5, so the output will be range of 1 comma 6. Am I right? What will be the output for range of 1 comma 6? It will be 1, 2, 3, 4, 5. Can we also have 6? No. No. Then it asks the values. In the next line, it starts asking the values. Enter one value, one name. Because we are using input function. We are using input function. So this input function reads the data from the keyboard and stores it in variable name. And the values that we have in the name, that gets appended to the empty list object initially. So that means all the 5 values that we pass get appended to the list object. And finally it returns the list object as it is. So this is the understanding of, the first function, read names. So this particular function, read names, is helping us to just read the names. Once after reading all the names of the list object, the second function helps us to display the names. How can we display? You just use a for loop inside the function. Job done. So def keyword followed by function name, and it is always advised to give a similar logical name to your function name. Disp names, display names. Then what it is accepting? It has a parameter and we are naming it as names. It is names. And indentation symbol followed by our block of statements. Initially it prints hyphens. How many? 50. 50 hyphens gets printed. Then we have a for loop for variable name in iterable object. So obviously our iterable object will be here list, because the values, the elements that we have in the list has to be displayed. So this names, okay, whatever the argument, the parameter that we have here should take our list object. Okay, and the values, the elements gets printed one by one. And once after printing all the names, it prints again hyphens 50. Very small, but simple. Right? So the first function for reading the names and the second function for displaying the names. Done. Then we have the third function for sorting the names. This is very important, right? Even in interviews, guys, you can expect these small programs, very small programs. Okay, so we are coming up with a function, we are defining a function which helps us to sort the names, which takes again a parameter st names. Okay, so using indentation symbol, then we are using sort function. Did we use sort function so far? Yes or no? Yes, we used. In which topic? In which topic did we use sort function? Sort function helps us to sort the data, sort the elements, sort the values. But in which topic? Very good. List. In list, we have discussed functions. Probably 11 to 13 functions were being understood. One of the function is sort. So what are we doing? We are using sort function, and by default, sort function sorts the elements in ascending order. By default, it sorts the elements in ascending order. Okay, so it sorts the list of elements, the values present in the list in ascending order, and it prints names in ascending order. Okay, and next to it, we are going to use the disp names function to display the names that got sorted in ascending order. The names that got sorted in ascending order. What if I want to get the output in descending order? I have to use a parameter called reverse. Inside the sort, there is a parameter called reverse, and I have to pass the value as true. The value as true. So by default, reverse will take false, which returns the output in ascending order. For descending order, we have to take reverse value as true. When we pass reverse value as true, the output will be in descending order. So the values, the elements present in st names get sorted in descending order, and we are going to print them using disp names, because disp name helps us to display the names one by one within the iterable object. Simple? Yes. So we are going to use all these three functions at a time, and we'll be calling them. Okay. So focus, guys. Focus. Right. I'm executing. This is function read names. Done. Then the second function, disp names. Done. Sort names function. Done. So all the three functions were being defined. Once after defining the functions, can we call the function? Yes, we can call the functions. What are we doing? We are calling the function read names. Read names function is being called. That means this function was being called. So let us have a look. Done. So once after calling the function, it is asking us to enter the values. First of all, how many values, number of values or the names would you like to have? Enter how many number of names. So probably I'll keep it as 3. So this executed and this condition did not satisfy. It went to the else block. It created an empty list object and it started executing the for loop, in which the input function started asking us, to enter the names one by one. I'll give the names as NEUT, next era Unitech. Then probably I'll give it as next era is the other name. And the third one is Unitech. So these are my 3 names. So what happens? All of them get stored. Where? They get stored in names. How come names were being stored? Here, you see, it will return a list object. Yes. And where are we storing it? In a variable names. In the variable names, what do you see? It is a list object of size 3. 3 elements. NEUT, Nextera, Unitech. 3 names. And we have the sizes for each and every name. Clear? Now, I'm going to sort the names. I'm going to sort the names. So for that, I'm using a if-else conditional statement. A if-else conditional statement is what we are using here. So if the names is equals to none. Okay. Do we have a none type value in names? No. No, the condition is not met. So it goes to else part and it initially prints 50 hyphens. Then followed by it prints original names. Then it executes disp names followed by sort names. So that means we are calling the other 2 functions. Display names and sort names functions are being called. So display names will display the names that are present in, the variable names. And sort names function will sort the names in both ascending order and descending order. So what will be the output, friends, if I execute this if-else conditional statement? What will be the first output? First output will be displaying. So initially it prints 50 hyphens. Yes. Then the for loop executes where it prints each and every element present in the list. So where the output will be NEUT, Nextera, Unitech. Then are we done? No. It also prints 50 hyphens. Again. Then, disp names function gets executed. So this line got executed. It goes to sort names function, where it starts sorting the values present in this list object in ascending order. So what will be the output for sort in ascending order? What will be the output we get for ascending order? Will it be same or different? It will be same. Good. For descending, yes. For descending, obviously it will be quite opposite to ascending. Right? So let me execute this. See, from here it started. 50 hyphens, then original names, yes. Then it executes disp names function. So it displayed all the names as it is. Then the sort names function started executing next to it. Ascending order and descending order. Is it clear or not? Simple. We just use the concept of, functions, but, we have actually extended ourselves. So far, we have tried functions, very small examples were being discussed. But here, the length of the function, the code became, we have just added more lines. So in this way, very small functions will be questioned in interviews. Create a function which helps us to sort the, elements of a list object. So you are supposed to create. Okay. So I'm just giving a random example. In interviews, your skills will be cross-checked in this fashion. That's it. Right. So if you are clear on the particular program, let us start understanding the next topic. It is approaches. I have to go back. So when it comes to functions, how to develop a function in Python? Okay, so there are multiple approaches, friends. Not in single approach we define or develop a function. Okay, so there are multiple approaches. Okay, exactly we have 4 approaches to develop functions. So the next topic is number of approaches to develop functions in Python. So in real time, we can define any function in 4 ways. In 4 ways. So let us understand what are the 4 approaches that can be used to define or develop a function. The first approach says, in approach 1, input will be from function call. The input we get from function call. Then processing will be from function body itself. Within the function body, the processing will be done. When it comes to output or the result, it will be from again the function call. You'll get the output or the result from the function call. Probably we are unable to understand, right? What is this approach 1? What is this input, output and processing? Yes, obviously within a function, it has to take some inputs. Once if it take any input, it has to give output, the result. This input has to be processed. Only then you'll get the output, right? So input will be from the function call and Even the output will be in the same function call only, but the processing will be done in the function body. So probably when you go through this, you may not understand. I'll take a few examples to understand how we develop programs, how we develop functions in Python using approach 1, right? So you remember this input and output from function call and processing will be in function body. For that, I'll go back. You see here, what are we doing in this particular function? Try to understand. What are we doing? What exactly are we trying to do here? Come on, guys. Are we defining a function? Yes, we are defining a function. Defining a function and naming the function as some OP, some operation, where we have two parameters, A and B. A and B. And what does a block of statement says? Just sum of the values. Okay, the values that we get A and B has to be added and stored in a variable NEUT, and this NEUT gets returned. Okay, so this is our function, a small function which helps us to return the sum of two values. So a small function, we are defining a small function to return the sum of two values. Now, this is an example of approach 1. I am developing a function, have developed a function, but do you see any inputs coming in the function? Function definition itself. Within the definition itself, do you see the inputs coming? No. No. I'm calling the same function here, right? Where the inputs are being taken from the function call. Where I'm calling the function in which the values, the inputs are being taken from the function call A and B. Here. And processing, once if you have A and B, the processing will be happened in the function body. Yes. And finally, when it comes to the result or the output, again, where do you see the output? Within the function call itself. Here itself you are printing. Okay, you are storing your output in a variable NEUT and that is getting printed. But within the definition part itself, we don't see any inputs or the output in the definition, function definition. They are part of, we are getting from, function call. So this is approach 1. Approach 1 sees input, you'll take it from the function call. The processing, anyways, it will be done in the function body. Okay. The result or the output will be from, again, function call. Okay. So let me execute. I'm defining it. Done. Yes. Just added some comments for better understanding. Okay. Anyways. Now, I'm using input function to read the data. So passing a value for A. So probably I'll give it as 8. And this 8, you see, it got converted to float and stored in A, 8.0. In the same way, we are also passing a value for B. 2. So obviously 2 gets converted to 2.0. Now, we are calling the function sum OP, we are calling it. When I'm calling the function, what values, what parameters are we passing? A and B. What are the values that we have for A and B? 8.0 and 2.0. So the inputs we are getting from the function call, not from the function definition part itself. And the output is getting stored in NUT. 10.0 will be returned. Yes. And I'm printing the output. So this is approach 1. Okay. So there are 4 approaches. In all the 4 approaches, these, taking the inputs and the output gets changed. Okay. That one thing you have to focus. Apart from it, rest of them are same. Yes. In approach 1, the input and the output will be from the function call, not in the function definition part. Okay. So let us also understand one more example where we'll develop a function using approach 1. This is approach 1 only, right? So what are we doing? We are defining a function and the name of the function is square root. The name of the function is square root. Yes. And what value are we passing? We are just passing one parameter n. So this particular function will return the square root of a number. What is this, friends? This is nothing but n power 0.5, which is nothing but n power 1 by 2, which is nothing but square root of n. So I'm defining a function which returns the square root of any given number. Again, which approach are we using? I'm using approach 1 to develop the function. How come? Because I'm not taking any input from, or even the result or the output will not see in the function definition part. You'll see in the call, function call. Within the definition part, do you see any inputs accepting? No. Do you see any output? In definition, function definition part? No. So we are using approach 1, and define the function square root. Done. It is done. Now I'll be calling the function where I'm passing a number to which I want the square root. So let me pass 25, which got converted to float. It becomes 25.0 and square root of x. X is nothing but 25.0, friends. So I'm calling the function and storing the output in res. So the output will be 5.0 and printing the results. Good. Simple or not? Yes, it's very simple. Now, so these are the examples that we have for approach 1. Let us also understand approach 2. What makes the difference between approach 1 and approach 2? You see, in approach 2, all the 3 input, processing, result or the output you see in the body itself. Within the function body, you'll get input. So the inputs will be accepted from the function body, and the processing anyways it has to be done in function body itself. Even the output or the results will be from the function body itself. Okay, so this is approach 2. Let us also understand few examples to develop functions using approach 2. Right? See, what are we doing? I'm defining the same function, some operation which helps us to return the what it is going to return. The addition of two numbers. The addition of two numbers. Alright. So within the function body, within the division, do you see the inputs? Yes. A and B. A and B. They are part of the function body. And I also see the output. Okay. So once after accepting the values of A and B, the addition it performs addition. Sum of A and B will be done and it gets stored in C, where it is also going to print the results as part of function body only. Okay, so I'm defining the function body. I'm defining the function sum OP. Done. Now, in order to call it, I just call the function. That's it. If I call the function, everything will be done automatically. See, it executes all the lines anyhow. Starting from enter first value, it starts executing from line number 3904. So it is asking us to enter the first value. So 5 and probably 5 again. So the inputs and the output were being from function body itself. This is approach 2. Clear? Anyhow, the processing should be done in function body only. Between these approaches, 1, 2, 3, 4, only the input and output, the places of these two values get changed. That we are trying to understand. So the moment we have called, it executed all the lines and we are able to see the output. I take the same function again, square root function, and let us develop the same square root function using approach 2. Simple. You add this input, the input taking should be part of the function body and the result part, the output part should be part of the function body. That's it. When you have both of them inside the function body, it will be approach 2. So this is the function which we are defining for square root of any given number. Right? So the moment you call the function, whenever you call the function, it executes all the lines one by one. See, it is asking us to enter a value, a number. I'm just passing 100. So immediately it accepts and returns 10.0. 10.0 will be the output. Clear? Yes. Then let us go and understand third approach, approach 3. Approach 3. In approach 3, the inputs will be from the function call. Processing anyways, it will be from the function body, but the result or the output will be in the function body. Okay, so the processing and the result, the output will be from function body. Only the input will be from function call. So this is approach 3. Developing functions using approach 3 involves inputs taking from the function call, then processing, and the result or the output will be in the function body. Clear? So I'll take the same functions, sum OP and square root functions, and I'll use approach 3 to develop the programs, to develop the functions. So what am I doing? I'm defining the function, sum OP, but do you see the inputs coming from the function body? No. The processing where the addition will be done and the output or the result will be again from the function body. So here it prints sum of x and y is equals to z. What is z? Z is nothing but x plus y. Okay, so I'm defining the function sum OP. Just have a look, friends. Done. Now I'll be calling the function sum OP. For that, I should have two values, a and b. So I'm using input and float functions to accept the values from the keyboard, and these values will be converted to float. So I'm passing a value. The first value I'll keep it as 5. And for b, again I'm keeping it as 5. These values will be stored in the variables a and b. See? They're getting stored in a and b. What type is being used? Float. Now, when we are calling the function, the values will be summed up and it returns the output. Sum of 5.0 and 5.0 is equals to 10.0. So this message will be printed where the formatting, the values gets formatted in the message. Simple, right? Then using the same approach, using approach 3, let us build the same function, square root. In approach 3, the processing and the output or the result will be in the function body. But the input will be from the function call. The input will be taken from the function call. I'm not changing the code. Okay. I'm explaining, the different approaches. How to develop Python functions. How to develop functions in Python. Right? But if you see, the functions are seen. You take sum OP or square root. Whatever we are trying to do, the logic is seen. Sum of two numbers and square root of any given number is the logics. And we are changing the program. The block of code that we have inside the functions is being changed according to the approach. You have to catch that single point. Right? So let me define the function first. Square root, done. Now, accepting the value for n. So it is asking us to enter a value for n. Probably, I'll pass a big number, 250. Then getting the square root of the number 250. So it is 15.8111, so on. Now, by this time, you should guess what will be approach 4. Approach 1 we have understood. Approach 2 also we have understood. And we have also understood approach 3. So what will be approach 4? It is quite opposite to approach 3. Quite opposite to approach 3. The input will be taking inside of function body, processing anyways in function body, but the result or the output will be given from function call. Quite opposite. You observe both of these two. Approach 1 and approach 2 are opposite of each other. Right? In approach 1, we have input and the output from the function call. In approach 2, both the input and the output we have it from function body. In approach 3, input is from function call and output is from function body. But in approach 4, input is from function body and output is from function call. Okay, so quite opposite, guys. Anyways, the processing will be in function body only. Whatever the approach, it will be from the function body only. Right? So let us develop the same functions, sum and square root functions using approach 4. See? Defining the function sum OP. Then what are we doing? Getting the inputs, taking the inputs from function body. The processing from the function body. And it is going to return C. Just it will return C. But when you call the function, so you'll also get the result. The result will be from the function call. Right? So the same logic, I'm not repeating time again. Just focus on the approach. Which approach we are implementing? Okay. Accordingly, you have to develop the function. That's it. Right? So let me execute. Here itself. Then calling the function. When you call the function, it will ask you the values. So passing 5 and 9. Done. But do you see any output here? No. Right? So let us print the output. Using same approach, let us also do it for square root. Do it for square root. What are we doing? Defining a function square root. Then accepting the values. It accepts the number, the input function, and for that number, it calculates the square root and it returns n and res both. The defined function, we are calling it, and multi-line assignment is what we are performing, guys, because two values we have here, right? M takes the number that was being passed and n takes res, the result. See, so let me pass 25. 25 is what we have passed. Yes. Now, printing the output using formatting. Yes. Or what I'm going to do? Okay, so I'm storing this, the result. Here, if you see, I'm calling the function square root, right? But where two values will be written, n and res, which gets stored in result. But result will be of type tuple. So it is asking us to enter the number. So I'll again pass 25. You see here, it returned us tuple. So the first one is our number and the second one is, the square root of the number. So we are printing this to the console using print function. So result of 0 will return the number indexing friends. Result of 1 will return the square root of the number 5.0. Clear? Right. So any questions? Right. So we are done with the approaches of, how to develop functions using these four approaches we have completed. Right. Now let us understand the syntax, because this is something we are supposed to do it initially, but we'll focus on the syntax for defining the function. Then we'll also go to the next topic. Right. So what does the syntax of the function says? Within the syntax, we have, two main phases. So this is where we are defining our function. The syntax is def keyword followed by the function name, then the parameters, if we have any, indentation symbol, and docstring block of statements. So this is our syntax for Python function. In order to define a function in Python, this is our syntax. So this first box is called function heading. This is called function heading. And the block of statements that we have is called function body. This is called function body. Right. Coming to the explanation. So we use a keyword called def for defining the programmer defined functions. The user defined functions? Yes. So in order to define any user defined functions, we use the keyword def. Then the function name should be a valid variable name. And this valid variable name is treated as the function name. And by default, the function name is considered as a function object. Yes. And the list of parameters The formal parameters represents the variable names used inside the function heading, and they are used for storing input values coming from function calls. From the function calls, you know, we have the input values getting stored. And this is something we have discussed earlier. Docstring. What is the purpose of docstring? Docstring represents a documentation string. Okay, we have a docstring inside the block of statements, and this helps us to describe the functionality of the function. Okay, so for better understanding and the best practice is always describe our docstring inside the function. And finally, we'll have the block of statements and they get executed. These are the executable statements which provides the solution for the given problem. Simple, right? And we also have the concept of local variables. In the next class, we'll be understanding what is a parameter, what is the arguments, different types of parameters and arguments. Okay, and followed by local variables. What are these local variables? What are these local variables? Local variables are the variables, okay, which are part of the function definition. So these local variables will be understanding to the depth in the coming session, right? So when you take a function definition, it is a combination of, a function heading followed by function body together. So both of these together represents the function definition. Right. So this is the overview of, the syntax and the explanation for the functions. In the next session, probably we'll be understanding the parameters, the arguments, as well as, the variables, types of variables, local variable, global variable, and we also have global keyword. Okay, then global's function. So all these topics we are going to discuss in the next class. Okay, so very important topics. Don't miss out the sessions, friends. Ensure that you are also being part of the live sessions because you'll be interacting and being learning, right? So ensure that you are present in the live sessions, right? Any other questions? If you have any other questions related to today's session or even internship, yes, your questions will be addressed. Yes. And moreover, friends, if you are part of the internship, ensure that you are submitting your assignments on daily basis. By end of the day, the work has to be updated. It The assignments has to be, submitted by EOD. Yes. Day by day, the sessions will be interesting, friends. Don't miss out the live sessions, especially. The main reason behind it is you will be interacting, and also you will be, understanding well. You can ask your questions, your doubts will be addressed. Yeah, you can upload. See, if you are unable to upload 2 files at a time, upload one by one. No issues, right? And friends, thank you for the feedback. Ensure that you join on daily basis. And if you find that the session went well, if it was interesting, hit on the like button and do share across these sessions among your connections. Along with you, others should also get benefited, right? So do share these sessions among your connections. Hit on the like button, a kind of encouragement that you are going to provide for us. Sure, we'll do it. Sometimes we'll be, extending, right? Yes, the feedback link has been posted. Give your feedback